How do you do, ladies and gentlemen, and boys and girls? I'm Julius Sumner Miller, and physics is my business, and more especially this hour, the physics of toys again, with which we have fun abundant. Now, I call to your attention. I have done some things with mechanical toys, some things with acoustic toys, some with thermally excited, energized toys. Now some electrostatic toys. A wonderful thing to witness. Here is a little box made of clear lucite on the top with a cardboard bottom. And in the box I have lodged some little figures in the shape of human figures, made of paper. Now what am I going to do? I'm going to stroke the top of this box ever so briskly but lightly with the flesh of my hand and watch. Ah, there they are. There they are. Dancing devils. Now, some are sticking here, and I want to know why they do that. Look at those little rascals. Look at that. Here is one of the same substance, really. Oh, look at that. Now watch. I'm going to put my finger on the upper surface here, and this little rascal down there can do many things. He can drop down, sort of dead, or he can flip away to another place on the underside of the cover. Watch. Oh, well, oh, there, that one did it. Let me show it to you again. Watch. Oh, that one went around. And the exploration of this would take a good half hour. An electrostatic toy. Let's look at a magnetic toy. Here is an iron framework. Iron, it has to be magnetizable stuff. It could be iron, nickel, or cobalt. Question, could it be stainless steel? Answer, no, stainless steel is not magnetic, which is a very interesting thing. And here is a little lucite wheel, which has an axle, and the axle is conical shaped on the very end. Conical shaped, quite like this. So somebody says, what are you making so much of this, Professor? Well, that's it, conical shaped. Why? The physics quite profound. Now what do? I lay the wheel on there. Now what I'm going to do is the following. I'm going to put this into motion mechanically. Down, up, down, up. Now I am in resonance with the moving of the wheel. Up, down, up, down, up, down, up, down, up, down, up, down, not quite. Not quite. Now, the beautiful thing about this is this. Here is an open end. And the wheel is held there magnetically at that open end. Very amazing problem. Because the magnetic force must be enough not only to hold the weight of the wheel, but to provide the centripetal force necessary to bring it around and up the track again. Or consider this magnetic toy. Here is one that is absolutely a killer to contemplate. Here is a little hollow sphere, which is loaded in the bottom with a little magnet. And you notice that mechanically it's very stable because it has a very low center of gravity. Now here is a little dog. The dog is called der Wunderhund, the wonder dog. A red one, a white one, a black one. Now as I approach the sphere with the dog, an interesting thing happens. Watch it. Watch it. Notice it spins. Let me approach another sphere with another dog. Notice this one goes away. The first one came toward me. Question, what's going on here? Well, I discovered what's going on by breaking away the front feet of the dog, and I found lodged in the front feet a little magnet. And the question is, how must this magnet and how must the magnet in there be polarized in order for these to do what they do. And in order to study that, here's what I did. I took a ping pong ball, cut it in two, put a little tacky wax in the ping pong half ball, and then a little iron sliver, which I magnetized in a very special way. And you watch. I'm afraid it may be too rough here, but watch. Yeah, get a little turning. And so I have explored it in this way in order to suggest to you how a study would be made of something you don't understand. Electrostatic, magnetic.